In this video, I will guide you through the configuration of a VPLS service on the NOKIA 7750 service router. VPLS stands for Virtual Private LAN Service. VPLS is a layer 2 service that connects multiple sites in a single LAN. It is an IP/MPLS based service, and it requires the exchange of labels between the routers within an ISP's domain. For ease of deployment, we will use the Label Distribution Protocol, also known as LDP. The LDP labels will provide us with the required support to configure and run service distribution points, also known as SDPs. Edge routers, which are referred to as provider edge routers or PE routers, are the ingress and egress points of the ISP's VPN domain. There are, however, many other intervening routers, known as the provider core routers or P routers, which are also running within the ISP's VPN domain. The P routers will normally have direct or indirect links between themselves and to the PE routers. An IGP protocol such as OSPF or ISIS is always required. Our major task in this lab is to build the bidirectional service distribution points and then implement VPLS service between the PE routers. We can class the configuration into two categories, with the configuration of the IGP and the SDP tunnels as the underlay configuration, and the configuration of the VPLS service as the overlay configuration. For this lab, we will require additional devices, which will be acting as the customer equipment. These will be used to test our configuration using traceroute and ping. I have broken our task into the following. Task 1 will be to remove the previously configured BGP. Task 2 will be to configure OSPF as the IGP protocol within ISP1. Task 3 will be to configure the LDP protocol on the PE routers. Task 4 will be to configure the SDP on the PE routers. Task 5 will be to configure the customer-facing access points on the PE routers. Task 6 will be to configure the VPLS service on the PE routers. Task 7 will be to configure the customer equipment. And lastly, Task 8 will be to perform our end-to-end testing. Let's now proceed with our Task 1, which says remove previous BGP configuration. To do that, we'll log on to the devices. To check what protocols are running at the minute, we issue the show router status on PE1. We can see BGP is running on PE1. Let's check the same on PE2. BGP is also running on PE2. Let's check CE1. BGP is also running on CE1. CE2 is new to the old setup. I don't expect BGP to be running on it, but let's show anyway. So it's show router status. Yeah, so there's nothing running on there's no protocol running on CE2 at the minute because it's brand new. I just brought it up. As you can see, I had to configure the card, the MDA as we did before. So if you've missed these steps, they are part of the playlist. So you can go back and watch how we did them. So let's go on to PE1 and remove BGP. And the command for removing BGP is very straightforward and simple. It's configure router return. We have to shut BGP down. BGP shut down. And then we remove it. No BGP. Exit all. Show router status again. BGP has been removed from PE1. Let's do the same on PE2. configure router, BGP shutdown, no BGP. Remove them PE2 as well. Let's go to CE1. Configure router, BGP shutdown, no BGP. BGP is removed from CE1 as well. Let's admin save our configuration. These are VMs and they have the tendency to sometimes reboot. We don't want to lose the little bit of work we've done. This has completed our task 1, which was mainly to remove the previous BGP configuration. Let's now move on to task 2. Task 2 says we need to configure OSPF as the IGP protocol within ISP1. If you remember, we had OSPF running on PE1 and PE2 in the previous video. Let's check and see what status the configuration is at the minute. So to do that, we issue on PE1 show router OSPF interfaces, because OSPF needs to be running into the core, within the ISP's domain, not with the customers. We can have scenarios where you can run protocols with the customers, but for this lab, we are only required to run an IGP within the ISP1 domain. And as you can see, the configuration on PE1 has that interface to the customer equipment running OSPF. We need to get rid of that because we don't need that. Let's check PE2 and see what's on that one. Show router OSPF interfaces. This is okay. This hasn't got OSPF running. So let's tidy up PE1. So we do configure router OSPF area 0. If we do info here, it will show us what the configurations we currently have. So we've got the system interface, which is always necessary, and we've got that interface to CE1. This is the interface we want to remove. So we go into interface. We have to shut it down before we can remove it. Interface to CE1. Shut down. Exit that. And then we'll issue the no interface to CE1. That's remove the interface going to the previous interface going to CE1. We now have to proceed with our requirement, which is to configure OSPF as the IGP within ISP1. Issue info here again. We only have the system. Let's go over to PE2 and also put the system interface within an OSPF area 0. Show router interface. We have the system interface, so we go configure router OSPF area 0 interface system return, exit, info. We have the system interface running. The next thing to do, if we refer back to our diagram, the interface we want OSPF on in this scenario is in between PE1 and PE2. I mean, we could have built the old network, but there's really no need for that. We just need to show you how you build SDP and enable LDP, configure the SDPs, and then run traffic from one site to the next. So the interfaces that we need to run OSPF on are the ones in between PE1 and PE2. So let's go back to the CLI and do that. So on PE1, if we also show the router interface, so we want the interface going to PE2. So here, we now need to add that interface. Interface to underscore PE2, return, exit, do info. We've got the system interface and the interface going to PE2 within our OSPF on PE1. We need to do the same on PE2. So interface, on this side we need the interface going back to PE1. Exit that, do info. Yeah, we have interface to PE1 from PE2, and we have interface to PE2 from PE1. Exit all. Let's verify. Show router OSPF neighbor. It's currently in two-way. I suspect there's an issue with the OSPF config. It's now full. It's just taking its time. Yeah, it's now full. So we have enabled OSPF as the IJP protocol within the ISP's domain. We also verified that PE1 and PE2 are OSPF neighbors with each other. We now move on to task 3, which is to configure the label distribution protocol on the PE routers. Our task 3 says we need to configure the label distribution protocol LDP on the PE routers. Remember, we need LDP to assist us with the configuration of the service distribution points. So we just need to enable LDP within the ISP's core. And to do that, we go onto the CLI and issue the required commands. So on PE1, we issue the configure router LDP. We then go into the interface parameters. It return. We need to add the interfaces here. So on PE1, we need to add the interface going to PE2. So if we do info here, we won't see anything at the minute because there are no interfaces, or there's no interface currently, but we now need to add the interface. So we issue the interface to underscore PE2. Exit, info, exit. Now you have to remember LDP, the default state for LDP is shut down. So every time you configure LDP or on an interface, you need to unshut it. you need to always remember to unshut it. It can easily catch you out if you don't. So we now need to issue the no shutdown command here, and then do info again. You will now see that it's now in no shutdown. We then go over to PE2 and do the reverse back to PE1. So configure router LDP, interface parameters, interface. On this side it will be interface going back to PE1 to underscore PE1. Exit, exit, info, just to check, no shutdown. We now need to verify LDP is running on those interfaces. To do that, we issue the show router LDP interface. As you can see, it's running on the interface going to PE2, and we go to PE2 and do the same thing. Exit all, show router LDP interfaces. Again, on PE2 we have LDP running on the interface connected to PE1, and the admin and operational status are both up. We can also run an additional check, which is to issue the show router LDP session. As you can see, on PE1 we have an established session going to PE2's system IP. We then issue the same thing. We go over to PE2 and issue the same thing, show router LDP session. Again, we have an established LDP session from PE2 going to PE1. This has concluded the task for enabling LDP on the core interfaces of ISP1. We now move on to task 4. Our task 4 is to configure SDP on the PE routers. Now, every SDP tunnel needs a numeric ID label. For the purpose of our exercise here, I'm going to use 2-digit label. You can make your own convention. It's not you can make it what you like, but it has to be logical to whoever's reading the configuration. So for our own purpose here, I'm going to create an SDP tunnel with the ID of 12, which is 1 to 2 from PE1, and then on PE2 I'm going to create an SDP tunnel going back to PE1 with an ID of 21, which is 21. So like I said, you can make up your own digits and convention. It's not restricted as long as it's logical to yourselves. You can. So let's proceed with the configuration of the SDP tunnel. So on PE1, this has to be done under the service. So if you remember, we've been configuring the LDP and OSPF under the router, but this time we are going under the service option on the NOKIA. So we go configure service, return SDP 1 to 2. Here you also have to be careful. We are using MPLS for our SDP. If I issue the question mark here, there are other options you can have, as you can see. So there are other options that you can have here, but for our own purpose we are going to use MPLS. And you always have to issue the create command. Otherwise, let's try it without the create and you'll see what I mean. So configure service SDP 12. If I don't put the SDP 12 MPLS, If I don't issue the create, you will get an error message. So create is mandatory while creating SDPs. So we now need to proceed and issue the create command. Hit return, and then the far end is PE2, and the system IP of PE2 is, just double check, interface. System IP of PE2 is 150.10.0.1. So far end IP is 150.10.0.1. Hit return. The label distribution protocol we want to use is LDP, so you need to issue the LDP keyword there. If you let's hit return, let's put the question mark and see what options we have here. So you have all these other options that you can use, but for our own purpose we are only concerned with using LDP. Hit return, and again, just like the LDP, you need to issue the no shutdown here. No shutdown, exit, exit, show service SDP. As you can see, it's currently down. Now the reason for this is because SDP is a bidirectional configuration. You cannot have a one directional or unidirectional SDP tunnel. There has to be a return path. This is why SDP 12 currently is showing us as down. This should change the minute we configure the return tunnel from PE2 to PE1. So let's go over and do that. So on PE2, configure service return SDP, and this we need to use the ID of 2.1. So from PE2 to PE1. And then don't forget the MPLS keyword, and of course the create as well. We hit return. Far end this time around is going to be PE1, which is 140.10.0.1. Whoops. 10.0.1, I believe. Let's just double check. Yes, it is. Hit return. LDP is our label distribution protocol, LDP. Hit return. No shutdown. Exit all. Show service SDP. As you can see, it's now up. If we go back to PE1 and issue that same command that failed previously, this one here, show service SDP, this should now show us as up. So show service SDP. Now the SDP from PE1 to PE2 is now also in admin and operational states of up, and the return tunnel from PE2 to PE1 is also admin up and operational up. This has concluded the fourth task, which was to configure service distribution point on the PE routers. We now move on to task 5, which is the customer facing access points on the PE routers. Our task 5 is to configure the customer facing access points, also known as SAP, on the PE routers. Let's refer to the diagram and double check what we currently have. So from the diagram we can see that the customer facing port on PE1 is port 113, and on PE2 it's also port 113. Now SAPs can only be configured on access ports that are set to Ethernet mode access. So let's go over to CLI and double check and make sure we've got all the right settings on the ports before we actually proceed with the configuration of these apps. So back onto the CLI, we issue the show port. Port 113 is currently up on PE1. So if we go configure port 113 and do info here, see, as you can see, it's just the basic default configuration, so this needs to be changed. Let's just check the PE2 as well and make sure show port 113 is actually down on this side. So configure port 113 info. Yeah, it's in shutdown, and also it's got the default config. Start off with PE1. So to configure the app, we need to verify and confirm the service access point. The port within the service access point has to be configured as a access port. So to do that, we go into Ethernet. We go into the port 113, Ethernet, and then mode. We need to change this to access. Okay, so this is a very good error message for you to see. If the physical port is already within an interface, a logical interface, you cannot configure it as an access port. You need to go and remove it from that logical interface before you can make any changes to it. If you remember, during the last exercise, we used port 113 to connect to CE1, and we had to create the interface to CE1. So this is what this error message is saying to us. There is an interface on port or channel 113, so you can't make any changes to it. So to correct this, let's go over to the, so let's do show router interface. So this is what the CLI is moaning about. The interface to CE1 currently has that port within it, so we cannot change it. We need to remove it from this interface, this logical interface, before we can make any changes to it. And to do that, we go to configure router interface, and it's to underscore CE1 hit return. If we do info here, we have to shut it down first as well. So shut down and then no port. We need to remove the port with that command. Exit all. If we now go back to the port configuration of 113, configure port 113 info. Now we should be able to change it. So if we go Ethernet, I have to shut it down. Shut down. Ethernet mode access. Now it's taking the command, and then we can unshut it with this command. We need to go over to the PE2 and do the same thing. We don't have that problem here though, so all we need to do here is go into the port configuration and do the Ethernet mode access and no shut. So we've confirmed that the two access ports are configured correctly with the Ethernet mode as access. We then proceed with the SAP configuration. So now we issue again show port. Our port 113 is still up. Go to the other side as well. Exit all. Show port. Port 113 is up. and it's configured as access, as you can see. Port 113 is configured as access on both sides. This has concluded the task 5, which said all we needed to do was configure the customer facing access points. In other words, you can say we're preparing the ports for the service access point configuration. We now move on to the next task, which is task 6, and this is where we actually start to configure the VPLS service on the PE routers. Our task 6 is to configure the VPLS service on the PE routers. To do that, we go over to the CLI and issue the configure service VPLS. Now, the VPLS also needs a numerical ID. For the purpose of this exercise, we're going to use 10. But before I issue the 10, I'm going to issue the question mark here for you to see the available amount of service IDs you can have. That is a lot. So for the purpose of our exercise here, I'm going to use VPLS 10, and we have to assign this to a customer. So customer, again, if you use the question mark, you will see the amount of customers you can also have. Again, that is quite a lot. For the purpose of our exercise, I'm going to say customer 1, and don't forget we have to issue the create keyword here as well, otherwise it will generate an error. So configure service VPLS 10 customer 1 create. We then go over and assign the SDP that we created earlier, the SDP going from PE1 to PE2. And to issue that command, we go and type in mesh SDP. The SDP ID was 12, so we create that within this VPLS 10. And then we now need to tie in the service port that we checked earlier, port 113. So we go SAP and type in 113, hit return. I needed to be out of that, sorry, exit, and then here we do SAP 113, hit return. Again, very good error for you to see. We need to always issue the create when we also create the SAP. So issue the create keyword, hit return. If we exit this now and issue the info, we will now see the VPLS configuration here. We've assigned that access port 113 within VPLS 10, and we have also told VPLS 10 to use the mesh SDP 12, which goes from PE1 to PE2. And next thing we need to do is issue the no shutdown. We now need to go and do the reverse on PE2. So configure service VPLS 10 customer 1 create mesh SDP. Here it will be 2.1 create, which is going from PE2 to PE1. Don't forget the create keyword. Exit out of that. SAP. Again, we have to use 113, the one we prepped up earlier. Enter. Again, very good error message for you to see. It catches everyone out. So we need to put the create keyword. Create. Exit out of that. Info. As you can see, the default state of a VPLS is always shut down. You need to issue the no shutdown. Exit all. Admin save for us not to lose the little bit of work we've done. Exit all. Now, if you see, whilst you're configuring the CLI and you see this little asterisk here, All that means is there are some configuration that are pending that you've not saved. So if I issue the admin save, you'll see that that asterisk disappears. So if you're wondering what that is, that's all it's saying to you. You've got some pending configuration that you've not saved. So we proceed. So let's verify our VPLS service is up and running. And to do that, we issue the show service ID 10 base. So it says admin state is up, operational state is up, service ID is 10, VPN ID is 0, service type is VPLS. These are all self-explanatory. You can read through them when you're building yours. The most important thing here is the SAP, which is the one facing the customer, and the SDP, which is the one taking this VPLS to the other side of the ISP's domain. And they are all up. So we go over to the other side again and issue the same thing. Show service ID 10 base. Same thing here. We've got the same thing going back. But there is something I'd like to show you actually. So it's saying here that the SAP is null, which basically means is the default SAP type. Now you can have Q in queue here, you can have .1 queue here, but this is out of scope for this exercise. Hopefully in the NRS2 exercises, which is coming after this, we will go deeper and you'll see the different types of SAPs that we can have on the NOKIA 7750. But for now, just know that the null is the default SAP type. So we proceed and check. We've checked the service, it's up, and then this concludes the configuration of the VPLS. We then move on to our next task, which says we need to configure the customer equipment. Our task 7 says we need to configure the customer equipment. But before we do that, let's have a look at the topology and recap on what we've done so far. So we have built the ISP network, we configured OSPF, we enabled LDP, and we built the service distribution points from PE1 to PE2. Now, we now have to connect site 1 into the ISP's VPN domain and also connect site 2 on the far end into the ISP's VPN domain. So picture a company that has bought a leased line from this ISP, and they've now provided them with a cable saying, there you go, connect that to your CE router on both ends and you can talk to each other. So whatever IP address you want to use, it's up to you. It's going to be transparent to us. We won't see it because it's all going to be labeled switched within this ISP's domain. But as far as these two devices are concerned, CE1 and CE2, to them it looks like see if they are connected into a switch. So they should be able to see each other. So that's the aim of this. So let's proceed with the configuration on the CLI. So we go to CE1 rather. Let's check what we have here. Show router interface, because if you remember, we were using this in our previous examples as well. So there you go. So we need to remove some of this configuration. Now, on the diagram, what we have connecting to the ISP network is port 111 on both sides. So we need to prepare those ports, configure them in the right mode. So we go into configure router interface. This time around I'm going to say interface to _ ISP1. But don't forget, I need to remove this port from within the previous interface. So to do that, let me go back actually. So let's go into interface, configure router interface to underscore PE1 info shutdown always no port. That's removed that port from within that logical interface. So if we now go back to our interface to ISP1, info, it's in shutdown, but we need to add a port. So port 111, and here we need to assign an address. It could be any address, like I said, it's transparent to the ISP. For our purpose, I'm going to give it the 192.168.0.1/24. Info, I need to issue the no shutdown. Exit all, show router interface. To ISP1, it's down, it's up, it's got port 111. We've removed that from the previous interface. We now need to go to the far end, which is CE2, log in and do the same thing here. So show router interface, we need to create it. So configure router interface. Again, let's use the same. It don't have to be, but for the purpose of our exercise, to ISP1. Port 1/1/1, address 192.168.0.2 on this side /24. Info, issue the no shutdown. Exit all. I just need to check something quickly. I can't remember if I configured the port 111 on this side. So show port. Yeah, just as I thought, port 111 is down. So configure port 111. All we need to do here really is no shut. Exit all. Show port. So if our configuration is correct, if there are no issue with the configuration, let's go back to the diagram and show you what we've just done. So if everything is okay with our ISP and our configuration, our VPLS service, everything, we should be able to ping from CE1 to CE2 on that interface. So let's try that and see what we get. So from CE1, if I ping 192.168.0.1, let's make sure we can ping ourselves first. Yeah, that is fine. So now I'm going to try and ping CE2, which is the .2 address. And as you can see, I can ping all the way through the ISP's domain, which could span multiple continents from site 1 to site 2. As far as these two devices are concerned, they don't know what's in between here. Everything is being label switched within the ISP's domain. It's transparent to them. Headquarters can talk to branch office, they can share files, they can do whatever it is that they normally do as if they are connected together in a switch. Let's, however, go back to the CLI and ping back the other way just to be sure. So again, I'm going to ping the local IP here, which is 192.168.0.2. That is working fine. Then I'm going to ping CE1 on the .1 IP. And again, as you can see, the reverse is also working fine. Admin, save that. I'm going to save all this configuration and share with you guys as a guide, not for you to copy and paste. just as a reference. It's very advisable that you build this yourself and you make your own mistakes. That's the way you learn things. You break it. It's a VM. If you break it, you can build another one within minutes. So don't be worried. Don't be scared about breaking and making mistakes with these things. That's the way we all learn. So I have actually done the last task myself, but let's do one last check, which is we're going to issue the trace route. So task 8 is perform end-to-end test using ping and trace route. We've just done the ping. Let's issue the trace route from CE1 to CE2. So if we do trace route to 192.168.0.2, as you can see, it's just one up. As far as CE1 is concerned, CE2 is one up away. That is the power of a VPLS service. So as far as CE1 is concerned, it just went all the way through the ISP's domain and boom, straight to PE2, unaware of what's in between. This has concluded our NRS1 series. NRS2 will be released shortly, and that is a lot more detailed than this. We will be using the NOKIA labs with a lot more routers. It's more detailed, it's more involved, but by the time you've gone through these exercises in NRS1, it's going to be a lot easier for you to follow. A lot easier. We're basically doing the same thing, but a lot more detailed. We're going to start to uncover and delve into a lot of other configuration that normally on NRS1 you really don't need to know about this for now. You just need to get your understanding right, understand how to configure all this basic stuff that we've been through. So hopefully you're subscribed, hopefully you're sharing this with your family, friends, colleagues. I also wish you good luck with your exam if you're taking the NRS1 exam. You still need to do some theory reading, but as far as the config and hands-on are concerned, you can always come back to this channel, review what we've gone through to refresh your memory. I wish you all the luck, and please don't forget to subscribe. Thank you.